In this video, we are going to state the law of large numbers and cover a few examples. So the law of large numbers states that for a sequence of random variables, so let's say we have a bunch of yi's with I equal 1 to n, they are random variables, and by random here, that's very important, we mean independent. So they are random draws from a distribution, an identical distribution for each variable. And this distribution has a mean that we'll call mu. The law of large numbers states that if we take the sample average, 1 over n sum of yi, this will converge to the expectation of yi. So that's very convenient. It will converge in probability. And it also implies that, for instance, if we take 1 over n sum of yi square, it will converge to the expectation of yi square. Actually, we can take a function of yi and take 1 over n sum of the function of yi. This will converge to the expected value of the function of yi. Be very careful. It's not the same as taking the function of the average yi. So since we know that what's inside the parentheses here converge to the expectation of yi, and using the continuous mapping theorem that we covered in the previous video, this will actually converge to the function of the expected yi. So you see the difference. Before we have the expected value of the function, and here we have the function of the expected value, and these are not equal. So let's cover an example. Let's take the estimator of the variance, 1 over n sum of yi minus y bar square. We would use normally 1 over n minus 1, but here it doesn't make a difference. So let's make some transformation. We know that this is equal to yi times yi minus y bar. If you don't know why, just check again the very first video of the playlist. This is equal to 1 over n sum of yi square minus 1 over n y bar sum of yi, and 1 over n sum of yi, this is also y bar, so we have 1 over n sum of yi square minus y bar square. Now 1 over n sum of yi square, this converges to expectation of yi square by the law of large number. And we know that y bar converges to expectation of y, although by the law of large number. By applying the continuous mapping theorem, so we have y bar converge to expectation of y, and by the continuous mapping theorem we hence have y bar square converge to expectation of yi square. So here 1 over n, the sum of yi minus y bar square, and we just saw that it's equal to 1 over n sum of yi square minus y bar square. This converges to, the first part converges to expectation of yi square, and the second part converges to expectation of yi, close the expectation, square. This is one of the definition of the variance of yi. So 1 over n sum of yi minus y bar square converges in probability toward the variance. We can make exactly the same reasoning for the covariance. 1 over n sum of yi minus y bar xi minus x bar. This will converge in probability toward the covariance of yi and xi. So in the next video, we are going to go over the proof of the consistency of the OLS estimator, and we are going to use all of these concepts.